In this video, we are going to be explaining the phenomenon of mountain formation. Okay, so I have here an animation. So if you have two plates and these two plates move towards each other like this, plate number one could be continental, meaning it has continental crust, and plate number two could also have continental crust. So in that case, if they collide, so you can see what's happening right now. So the materials at the point at which they meet would really crumple upwards. So there's a crumpling effect when the two plates meet. So um, continental crust is really very light. It's less dense. And also, since both of them involve continental crust, then both of them are lighter. And therefore, when the crusts collide, nothing, none of the two plates would sink under the other because both of them are light. Both of them float on top of the atmosphere. So if that's the case, then when they meet, there's really nothing to do but really thicken that part at which they meet. So you can see here that the materials thicken to the bottom, but obviously at the bottom there's the ionosphere, so the materials cannot really go downwards. But upwards, it's okay because there's only air here. So the materials, the rock layers get crumpled upwards, and you have a very thick crust there. And that thick crust, we see that as mountains today. So, but take note, this only happens when you have a continental plate and another continental plate colliding. So you have mountains, or in fact, it's not really a mountain, but mountain ranges, meaning it's a line of mountains that are being created. So if we look at the map of tectonic plates here, right? If we zoom out and then we zoom in somewhere where we can find an example of that. So here on the edge, you have the Indian plate, and it is colliding with the Eurasian plate, right? So this Indian plate goes this way, this Eurasian plate goes that way, so they are colliding. And you see, this is continental land, and also this is continental land. So therefore, both of them contains continental crust. So when they collide, you have this crumpling effect, and you see a line of mountains here bordering Eurasia and India. Okay, so if we have our Google Earth here, let's search for that. Himalayas. So if you look at these are the Himalayas, and again, if you zoom out, for those who missed it, this is Eurasia, and this is India here. Let's zoom in so that it's clearer. This is India. So India is moving that way, this is moving that way, so they collide on this boundary. And what do we see at the boundary? We see these mountains here, and at first they might not look mountains, but if I turn on the 3D part here and zoom, so you can see this line of structures here. That's the border between India and the rest of Eurasia. So if we zoom in, you can really see all of these mountains. So these are not just one mountain, but really like a chain of mountains. That's why we call it the mountain ranges. So here you can see the mountains from the zoom from space are actually like just the crumpled crustal material, because again, the Indian subcontinent is colliding with the Eurasian plate. Therefore, the crustal material gets crumpled upwards, forming mountains. Obviously, Mount Everest is part of this, and Mount Everest is the tallest mountain in the world. And in fact, Mount Everest is growing centimeters each year because of this process. So again, because the process involves two crustal material, it's reset so that you can see how it's done. Continental crust and continental crust. When they collide, again, the material crumple up little by little because remember the plates move in centimeters per year. So therefore, Mount Everest right now is growing inches or centimeters per year. So if you climb Mount Everest now and you say, I climbed the tallest mountain in the world. Technically speaking, after 10 years, 5 years, that means you have not climbed the tallest mountain in the world because it has now become even taller than when you were there last time. But anyways, that's the idea. So you see this mountain, we know that mountain ranges or the mountains of the world can be built when you have two plates that are colliding and those two plates are containing continental crust and continental crust. Again, when you have continental crust and another continental crust, or two plates with continental crust, these two crusts are light, so less dense, so light that they don't really sink. So what they do is when they collide with each other, all they can do is crumple upwards, and you see these folds and crumpling up. That's why in some books we call this fold mountains because they are technically created by you know when the two things collide, they kind of crumple, and therefore there's some folding of the ground. The rock layers are being like deformed and like that. So that's how mountain ranges are created.